Welcome back to the session number 8 from the playlist of oscillations. The topic is the periodic and the simple harmonic motion. And based on this topic, I have selected one question from one of my reference book. The question here is, the displacement of a particle is given by y is equal to sine cube omega t, where omega is the angular frequency and y is the displacement of the particle at any moment of time. So the motion is, there are four options here and we have to find the correct one. The options are, first option is, the motion is periodic but not simple harmonic. The second option is, the motion is periodic and simple harmonic motion. The third option is that the motion is non-periodic, and the fourth option is that the motion is simple harmonic motion with a frequency of pi by omega. So before proceeding with this question, let us first of all go through the definition of the periodic motion and the simple harmonic motion. Now the periodic motion is a motion which repeats itself after a fixed interval of time. The periodic motion is an oscillatory motion or the vibratory motion when the body or the particle moves back and forth about a mean position. And the oscillatory motion or the vibratory motion is a simple harmonic motion if the acceleration of the particle is directly proportional to the displacement, or the acceleration of the particle which is executing the simple harmonic motion will be governed by this relation, that is d square y upon dt square plus omega square y is equal to 0. That is, if the particle is executing the simple harmonic motion, then the acceleration will be directly proportional to the displacement, first thing, or we can say that the acceleration of that particle will be governed by this equation, that is d square y upon dt square plus omega square y is equal to 0. So I will be writing this equation here on the top of this board. Now here the displacement of the particle is given by this equation, that is y is equal to sine cube omega t. So simply what we have to do is, in order to find whether this motion is a simple harmonic or not, we will first of all simply differentiating this equation twice, and after differentiating this equation we will be getting an equation, and if that equation is resembling this equation, then we can say that this particle is executing simple harmonic motion. Now any motion which is a sine function is always periodic. The first thing is clear that this motion is periodic. Now only the we have to find here is whether this motion is simple harmonic or not. The first thing is that I will be differentiating this equation with respect to t. So dy upon dt will be equal to, now in order to differentiate this equation, what I will be doing is that I will be considering this sine omega t as u. So this equation will be equal to y is equal to u cube. So if y is equal to u cube, then dy upon du will be equal to 3u square. And if sine omega t is equal to u, then du upon dt will be equal to omega cos omega t. So dy by dt is equal to dy by du into du by dt. So dy by du is equal to 3u square. So u is equal to sine omega t. So I will be just putting the value of omega as sine omega t, and this is u square, so it will be sine square omega t into du by dt is omega cos omega t. So dy by dt is equal to 3 square sine omega t multiplied by omega cos omega t, or we can say that dy by dt is equal to 3 omega into sine square omega t into cos omega t. Now I will be differentiating this equation once more in order to get the value of d square y upon dt square. So d square y upon dt square, this will be equal to, now here 3 omega is a constant, so I will be just taking it outside, and here I will be using the formula, that is if y is equal to u into v, this is called the product rule. So if y is equal to u into v, then dy upon dt is equal to u dv upon dt plus v du upon dt. So here what I will be doing is I will be considering this sine square omega t as u and cos omega t as v. So d square y upon dt square will be equal to the differentiation of first of all I will write the sine square omega t, and the differentiation of cos omega t will be equal to minus omega sine omega t, then plus cos omega t into the differentiation of sine square omega t. So if I take let us say sine, let us consider that y dash is equal to sine square omega t, and so this y dash will be equal to u square if sine omega t is equal to u. So from here you can find that dy dash upon dt will be equal to 2 times u into the differentiation of this, this will be equal to dy by du into du by dt. Now dy by du here is 2u and du by dt will be equal to omega into cos omega t. So here the value of this means the differentiation of this term, that is sine square omega t with respect to t, will be equal to 2 times u into omega cos omega t, where u is equal to sine omega t. So I will be putting this value here. So this will be equal to 2 times u is here sine omega t into omega into cos omega t. So this is the value of the d square y upon dt square. So from here I will be getting the value as 3 omega. This will be equal to minus omega sine cube omega t plus this will be equal to 2 times omega into cos square omega t into sine omega t. So this is equal to, if I, now what I will be doing is I will be simply opening this bracket, so this will be equal to minus 3 omega square. Now sine cube omega t is equal to y, so I will be putting the value of sine cube omega t as y, and plus 6 omega square cos square omega t sine omega t, or simply we can say that d square y upon dt square plus 3 omega square y is equal to 6 times omega 6 omega square cos square omega t into sine omega t. Now here we if I compare this equation with this equation which is written on the top, which is the equation for the acceleration of a particle which is executing the simple harmonic motion. So this equation is not resembling this equation, because here d square y upon dt square plus 3 omega square y is equal to 6 omega square cos square omega t into sine omega t. If this term was equal to 0, that is d square y upon dt square plus 3 omega square y is equal to 0. If it was 0, then this motion would have been a simple harmonic motion. So here we can see that this equation is not resembling the equation of the acceleration of a particle which is executing simple harmonic motion. So this or in other words, we can also say that here that this motion, that is here the acceleration of the particle is not the acceleration of the particle, that is d square y upon dt square, is not proportional to displacement. Okay, and because of that, this motion is not simple harmonic, and you can also compare this equation with the equation which is written on the top. The equation which is on the top is the equation for the acceleration of a particle which is executing simple harmonic motion. So this equation and the equation which we have derived for the displacement of the particle given by this equation are not the same. They are not resembling each other. So, but because this is the displacement of this particle is a sine function, therefore this motion is periodic. But because this the acceleration of the particle is not directly proportional to the displacement, or in other words, this d square y upon dt square plus 3 omega square y is not equal to 0. Therefore, this motion is not simple harmonic motion, and we can say that the correct option here will be that this motion is periodic but not simple harmonic. That is, the option A is the correct one. So thank you very much for joining this session. In the next session, I will be coming up with a different type of a question based from the same topic, that is simple harmonic motion. So till then, have a nice day. Bye.